Good evening to one and all present here. I, on behalf of the Department of Computer Science, University of Madras, MHRD RUSA 2.0 Biomaterials team, welcome you all to the inaugural function of International Congress on Industry Perspectives of Data Analytics. Let's begin our session with Tamil Thai Valtu.
வாசனை போல் அனைத்தும் இந்த முறை இருந்த பெரும் தமிழனங்கே உன் சீரமை திறமை என்று செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
Self-belief and hard work will always earn you success. Now I request Professor P.L. Chitra Ma'am, Principal Investigator, Department of Computer Science, University of Madras, to present the welcome address.
Most respected Professor Dr. A.K. Munirajan sir, ever supporting colleagues, PA of this International Congress on Industrial Perspectives of Data Analytics, Dr. Mrs. M. Sornam, Dr. B. Lavanya, the eminent speaker of this today, Dr. Mr. T. Sivakumar, co-partner, Deduce Applications, former Senior Director, Projects, CTU, Honorable Vice Chancellor, Registrar, team leader, along with our leader, Dr. E. Murugan sir, ladies and gentlemen, dynamic participants and research scholars, professors from University of Madras and other universities across the country, happy afternoon. It is indeed my great honor to propose welcome address for this August virtual gathering on International Congress on Industry Perspectives of Data Analytics, Nanoinformatics on the role of NanoHab in cancer imaging, orthotendonics and orthopedic schema and system design. Education is the most powerful weapon which you can use to change the world, said by Dr. APJ Abdul Kalam ji. This is particularly true in our big data analytics field. It is indeed a great pleasure to welcome our eminent chief guest of this today afternoon, Dr. A.K. Munirajan, Professor and Head, Syndicate Member, Department of Genetics, Director, Dr. ALM, PG Institute of Basic Medical Science. Welcome you, sir. We are honored with your presence. I am happy to welcome the resource person of today's session, Mr. T. Sivakumar, co-partner, Deduce LLP, former Senior Director, Projects, AMBU, CTS, and our own alumnus of the department. We are very happy with your presence, sir. Welcome you, sir. It is my pleasure to welcome all our beloved professors from University of Madras, Government College and affiliated college, professors, faculty across the country to this forum. It gives me an immense pleasure to welcome dynamic young research scholars, PG students across the country to listen to industry perspectives of data analytics. I am happy to welcome you once again, everyone present here. So I would like to, this is a time to talk about 2 minutes about our program. So this international congress aims to give domain expertise from reputed industrialists who is going to explain data processing methodologies with real world examples, data visualization tools, which will facilitate to upgrade and encourage young brains to pursue research. The focus area of this Congress: case study on data analytics, deep learning techniques, healthcare image processing, recent advancement in prediction tools, robotics process automation. So we have all our eminent speakers from reputed industries and research organizations from national and international level to handle the various sessions. I welcome you all for this international congress, for having the happy learning of the various tools which are available in this domain in our IT field. I am happy to welcome you one and all present here. Thank you.
To be inspired is great, but to be an inspiration is an honor. Now I request Associate Professor B. Lavanya Ma'am, Principal Investigator, Department of Computer Science, University of Madras, to introduce as chief guest Dr. A. M. Munirajan Sir, Professor and Head, Department of Genetics, Director, Dr. A. L. M. PG Institute of Basic Medical Science, University of Madras.
Good afternoon to one and all present here. It is my honor to welcome our chief guest, Professor A.K. Munirajan Sir, Head Department of Genetics, Director ALM, Dr. ALM PG Institute of Basic Medical Sciences, Member Syndicate, University of Madras. Welcome you, sir. It is an honor to introduce him to the participants. He has received his PhD in cancer biology in 1996, and he has a postdoctoral experiences in various geographical locations in universe. He has done his PDF in Division of Biochemistry, Shiba Cancer Center, Research Institute, Shiba, Japan. And then he has done his PDF in Department of Genetics, Boston University School of Medicine, Boston, USA, and PDF Associate as the Department of Molecular Cellular Oncology, Tokyo Medical and Dental University, Tokyo, Japan. And he has served in various capacities in his own department and in the University of Madras, like Director, Professor and Head and Professor. He has received over 12 eminent awards. To state a very few recent awards, he has received a Tamil Nadu Scientist Award TANSA 2019 in Medical Sciences. And then in 2016 to 2021, he was honored with NIG Collaborative Research Grants, National Institute of Genetics, Japan. And in 2019, he has got Best Researcher Award from our own University of Madras. And from 2015-16, he has DHR Short-Term Fellowship Program in National Institute of Genetics from Department of Health Research, New Delhi. And the list really goes on. He has various achievements. He has established Directorate of Health Research, Multidisciplinary Research Units with a research grant of 5 crores, 5.25 crores, and recurring grant of 34 lakhs per year in Dr. ALM PG Institute of Basic Medical Sciences, University of Madras, Taramani campus. And he is now a syndicate member, University of Madras 2020-21 to 2023. And he's an academic council member for over a few years. And then he has an MOU with University of Naples, Federico II, to participate in the joint international doctorate program in molecular oncology and endocrinology and exchange research students. And he's a UGC CAS advisory committee member, a coordinator UGC SAP DRS2 program, Department of Genetics, University of Madras from 2013 to 2018. And he is a DBT nominee, Institutional Biosafety Committee, IIT Madras, Anna University, Chennai, and is a member secretary of Institutional Biosafety Committee, University of Madras. And again, the list goes on. And he has a research grants of whooping 5 crore and 65 lakhs worth grants, to name very few ongoing projects. He has a copy number associated microRNAs and the diagnostic potential in autism spectral disorders from Indian Council of Medical Research, 44 lakhs worth projects going on, and fine mapping of 9p21.3 genetic loci associated with coronary heart disease risk in South Indian population from Indian Council of Medical Research India, around 50 lakhs. It's again an ongoing project. Investigating the miRNAs as potential biomarkers to classify autism phenotype for clinical management from Department of Biotechnology India, with 53 lakhs worth projects again ongoing. And molecular dissection of hypoxic signaling network, its clinical implication in head and neck cancer from Indian Council of Medical Research India, 50 lakhs worth projects ongoing. And epigenetic of cognition as a biomarker for early psychosis from DST Cognitive Science Research Initiative, around 59 lakhs. It's again ongoing project, and a huge list of already completed projects. He has over 50 international publications and has over conferences and seminar, 40 conferences and seminars as chairpersons and chief guest alone. Sir, it's indeed
Lavanya, maybe you are wasting too much of time.
No, sir, it is actually an inspiration for all of us seeing your achievements.
Yeah, please, they will find out who is this fellow who is introducing. So you don't need. It's enough.
Sir, we are really thank you for accepting our invitation and joining us as a chief guest, sir. Thank you, sir, and welcome, sir. The floor is yours now.
Yeah, thank you. So am I audible?
Yes, sir.
Yeah, thank you. Thank you for the nice introduction. And I'm happy to know that under the MHRD RUSA 2 biomaterial, through the biomaterial section, and the department Department of Computer Science is organizing a seminar, and under the aegis of International Congress on Industry Perspective on Data Analytics. And I'm happy to associate, maybe the only one word I heard about is cancer biology. So rest of the things, I know that the data is expanding, the advent of next generation sequencing and even the digital technology, all the data, even with reference to cancer, it's getting expanded, and definitely we need a systematic analytical tools to identify and isolate. Even last week, when pathologist was presenting a endowment, and she claimed that this digital technology or with the AI combined will be replacing the pathologist. So she is worried about the pathologist job. So you can understand the real effect of this big data in healthcare and the analysis, data analysis or machine intelligence, what it will be doing in future. Like, you can very well understand the molecular pathologists are worried about this. So that is the power of this, the emerging area, and going to overlap with the biology. And I'm sure like you will be enlightened with the lectures like data analytics and machine intelligence, and data analytics with business intelligence, integrating robotics, process and automation, and with data analytics, and trends in advanced analytics, digital twins in healthcare, and relevance of machine learning in today's world. So I'm sure like you will be enjoying, and pay attention to the lectures, and don't be a mute spectator. So you will be also, by means of interacting or asking a few clarification, you are honoring the speaker, and he will be happy to know that you have understood something, or he is able to give some amount of knowledge that you can come forward and ask something. So that is the things most of the speakers will be expecting from you. And I think I congratulate the computer science department for thinking of this kind of workshop, the seminar, and bringing experts from different walks of life. And I'm sure the industry is definitely looking forward to identifying the domains where they could even overlap or support the basic science researcher In fact, we are also in the lookout for the bioinformatics analysis. We are having extensive data generated through next generation sequencing, methylation and RNA sequencing, small RNA sequencing, and even mutation screening. So it will be also helpful, like for us, this domain, it will develops to a level, and that will also progress the research. And even if you go to the healthcare and cancer research also, by combining all the data with the available electronic records, even this big data analysis can find out what we are unable to do as a researcher with the limited potential of our brain. So maybe this data analytic and the different methods what people are developing and going to talk about, I hope it will yield a methods where it can help you to rate or screen or identify a biomarker or screen the potential digital images that can be associated with good prognosis or bad prognosis. And all those things are going to be like the real outcome of this new avenues that is being developed and getting interfaced with biology. So I wish you all the success for the conference, and I hope you all enjoy with the different people with the industry and basic background coming and giving you the different perspectives of data analytics. Thank you.
Now I request Associate Professor B. Lavanya Ma'am, Principal Investigator, Department of Computer Science, University of Madras, to present the vote of thanks.
I take the privilege of rendering the vote of thanks on the starting day of the MHRD RUSA 2.0 sponsored International Congress on Industry Perspectives of Data Analytics. Let me thank the Almighty for His grace on us during this period and for His blessings, blessing us to continue our academic and research activities. I thank the authorities of University of Madras, Professor Dr. S. Gauri, Vice Chancellor, for his support in conduct of this workshop. I would like to thank Professor Dr. N. Madhivanan, Research Registrar in Charge and RUSA 2.0 Coordinator, our team coordinator, Professor Dr. E. Murugan, and our dynamic group leader, Professor Dr. S. Balakumar, Director, National Center for Nanoscience and Technology, for his continuous encouragement and unceasing support for initialization of this project till date. I thank our chief guest, Professor Munirajan sir, for his cordial presence and his thoughtful words. I thank the fellow participants, research scholars and students from various universities, colleges and research institutes pan India. I thank our professors, Dr. P. Thangavel and Professor Dr. S. Gopinathan sir, for their support. I thank the conveners of this workshop, Professor Dr. Chitra, Professor M. Swarnam, for the untiring work for conduct of this program. We, the conveners of this program, expect the same support from all participants throughout this week. As mentioned already, it is definitely going to enrich your knowledge on the most wanted hot research topic, analytic tools from industry perspectives. Thanks to this pandemic, we are fortunate to get the virtual knowledge sharing from eminent resource persons, both nationally and internationally. So participants do not miss even a single session. Thank you once again for your patient listening. Thank you.
Let us start our session with the topic Data Analytics with Business Intelligence. Now I request Dr. B. Lavanya Ma'am, Principal Investigator, Biomaterial Team 2, Department of Computer Science, University of Madras, to say a few words about our resource person, Mr. T. Shivakumar sir, co-partner, Views App, LLP, former Senior Director Projects, AIM, BU, CTS.
Welcome, sir. Welcome, Mr. T. Shivakumar sir. And a very few words on introduction about our today's resource person. Mr. Shivakumar Tandavamurthy, with 29 years of data and information management experience, provides solution in enterprise big data integration, enterprise data warehouse platform migration, data strategy, data governance, and business analytics. Having successfully implemented multiple data integration, transformation, governance initiatives in premises and or on cloud aligned to their process and data strategy. designed and delivered solutions that remedy core business issues by providing thought, leadership, and ownership from strategic planning for mission critical applications. His domain expertise mainly in banking with various products such as personal and private banking, wealth management, insurance, cards, and loans. And he has been a delivered technology transformation programs on data warehouse and business intelligence projects, and MFDB2 to Teradata, UDB DB2 to Netezza, Sybase IQ to Big Data, visualization technology changes to Tableau and Quick View. For large USA banking customers like KeyBank, American Express, Wells Fargo, Washington Mutual Bank, and so on. To meet the end results cost reduction, near real-time update to prevent fraudulent transactions, meet SLA with 100% compliance, proper data lineage, and expand business opportunities. Successfully maintained and made data warehouse applications stable and optimized for large USA and Europe banks. He has been part of core team in design and development of home/vehicle loan product, that is SmartLend, for Sundaram Finance. And he has managed a portfolio size $150 million in Cognizant as senior director projects. He has worked on analytics and information management business usage and global delivery lead for US West and Midwest regions and Europe region. Sir, we are indeed honored to have you as our resource person for the initial first day. The floor is yours, sir.
Thank you. Let me share my screen. Host disabled participant. Can you give me the access to share?
Oh, sir. Yes, sir. I think you can try now, sir.
No, not done yet.
Okay.
Or do you want me to send it by mail or?
No, sir. It will allow, sir. Ma'am, sir, can you please?
Jenny, can you please?
Yeah, you can start now, sir.
Sorry?
Can you try now, sir?
No, it said when I say start share screen, I'm getting a host disabled
Participant screen sharing.
No, ask Jenny to stop the screen.
No, she has stopped it.
Ma'am, I have already stopped sharing, ma'am.
Okay.
Yeah. But we had enabled it in the settings. We need to go to settings and then enable it again.
Host, make him as host.
Yeah. Jenny, can you do it?
Or I can send you.
Yes, ma'am, I'm working on it, ma'am.
The email, I can send it by mail.
Yeah.
Do you want me to send it by mail?
Like he's doing it, she's doing it. By the time you can also please, if possible.
Can you someone share the email ID so that?
Yeah, Jenny, share your email ID so that it can be easily shared. Share it in the chat box.
Yes, ma'am. We can share in the Rusa mail itself, ma'am.
Rusa mail ID, you need to share the Rusa mail.
What's the email ID?
Rusa to, it's in the chat box, sir. Rusa2dcs 2021.2023@gmail.com.
Chat box, okay, I'll take it.
Yeah. But we had enabled it. I don't know how it is. In fact, we had enabled multiple screen sharing also.
Can you check? I sent it is 1 MB file, PDF file.
Okay.
Have you got it?
Yes, sir. I'll share in a minute, sir.
Okay. While waiting, good afternoon all. I think you heard about Lavanya, about my experience. I'm predominantly working on data, primarily for banking for many years. I also worked in the domain pharmaceutical and telecom, just for your information. The topic is what we are doing in the industry on data analytics and business intelligence. Instead of getting too much into the advanced level, I thought of first talk about fundamentals, foundation of data analytics and business intelligence. We'll start with that, being this is the first session. The subsequent sections, probably you can go in advanced mode. So accordingly, I made the topic as foundation of data analytics and business intelligence. Still, it's not appearing. I will quickly show the agenda on what we are going to cover. So first we'll cover about why is analytics important. Okay, it is come up. Good. I could see that. Screen, are you able to see the screen? Can someone acknowledge?
No, sir. No, sir. No, sir.
Okay.
Not yet, sir.
Not it?
Not yet.
Oh. No, but have you received the mail?
Yes, sir. We have received the mail. Yeah, she's doing it, sir. Maybe she has to download and then share it. Yeah, she's sharing it, sir. Yeah.
It says come, sir. We can start.
Yeah. You can go to the next slide. Yeah. So first we'll talk about why is analytics important. Let us make it as an interactive. Whenever there is a clarification you need, you can stop me. You can ask questions. Okay. Again, as I mentioned in that title, it is foundation or fundamentals of data analytics and business intelligence. How we create the environment for data warehouse or data analytics. That's what we are going to cover today, being the first session. Subsequent sessions, we can go in advance. What kind of data we collect? What was the traditional MIS challenges? The information action value chain, and then end users analytics. Who is the end users for analytics? We are giving analytics, but who is going to use it? And then real-time analytics. What is mean by real-time analytics and why we need? Definition of data analytics and business intelligence. And then what is the difference between data analytics versus business intelligence? And then what we need to consider when you come up with a data management environment. And what you need to consider when you move data from different layers. And then we'll talk about the reference architecture. We'll spend more time on reference architecture. And then sample dashboard, BI dashboard for banking. And then very high level analytical use case. This is the agenda. We can move on to the next slide. So why is analytics important? You can think about how much of analysis you do at home. Are we doing any analysis at home? Typically very less if somebody is doing. At home, it is mostly decisions are made based on trust and emotion, not based on data. We never ask someone if you give some money to your servant or to the you are better off if they go to the grocery shop and come back. If they say this is the money I spend, whether it is 1,000 rupees or 10,000 rupees, whatever, you just take it as a trust. You won't ask the breakup. Give me the details. Okay. And but that will not work in the corporate world. So everything we need data. Everything, whatever we talk, we need to have data to substantiate. So that's why data is important. In organization, for every level, there is a clear defined target. And how do we track those? If you take banking as an example, there are multiple subdivisions within banking: personal banking, private banking, health, wealth management. For each and every LOB, we have a target. So they have to work towards the target, and they have to maintain multiple metrics. We'll call KPI also, key processing indicators. There will be multiple metrics they have to maintain, and they have to keep showing the progress. So this is the reason why we need analytics. And also where you should know where we are now and where we want to go. Even to come up with that, we need analytics. Every business aspect has too many variants to track, which I already told you. And also you need to know what your competition is doing. Based on that, you need to come up with some strategy changes. So some new products you may need to initiate. If your competitive banking is come up with some new loan product or some new insurance product, you need to think about how you can compete with them, right? For those things, we need analytics. Next slide, please. So kinds of data, what we collect. Most OLTP system, OLTP means online transaction processing. Most OLTP systems collect numbers, date, and text. This is the data we collect from the system of record. Like if you take banking, you are all doing banking, online banking, mobile banking, or you go to the branch and do some transaction. Everything, predominantly we call all these as OLTP systems. From these systems, we are capturing numbers, date, and text from all your transactions. And OLTP data are based on event or transaction. Either you might have given some simple instruction that every month I want to move this amount to this particular account or to this policy, something like that. And OLTP data is controlled by validation and authorization level. Not like the next point is social media data. There is no control, there is no authorization. Whereas OLTP, it all goes through controls and authorization. Only authorized records or controlled environment records will get into data warehousing or analytics in source. And the social media is open to the world, no validation. And we are doing a lot of NLP related data processing also. Nowadays, IoTs send a lot of sensor data. It used to be less. Now you can see sensor everywhere. If you see the diagram around your house, so many things. Everybody is sending a lot of data through sensors, IoT devices. These sensor data, IoT device data is either time-based or event-based. Even at, you can sit at your office, you can control your microwave from office. Okay, you can sit at home and you can do the remote start of your car. You can monitor what is the petrol availability on your car using IoT device again from home. You don't need to get into the car. Like that, for each and every usage, there are a lot of data coming up from IoT devices. Very near future, the number of IoT devices will surpass the number of PCs and mobiles in the in coming days, in coming years. Next slide, please. See, even though we are talking about business intelligence now, we were used to get a lot of traditional MIS reports. MIS is Management Information System. We used to get reports on paper. When I started my career around 90s, early 90s, I was doing project for Citibank. We used to print so many bunches of printouts. For each branch, it will go within the branch, multiple heads, it will go different reports. And these reports, these MIS typical reports are passive in nature. Once generated, we cannot further act on drill down. You can just see on the paper, then it has been come up on the screen, but you won't do the drill down and all. So altering the format was also a pain. So now colors, no appeal. So does not catch eyes. So when there is when you see numbers on a tabular column, it is not, it will not register well on your mind. Whereas there is a difference between left-hand side report and right-hand side. I don't know whether you can zoom and see. Am I audible?
Yes, sir.
Yes, sir.
So is it visible? The report pasted on the bottom, is it visible? Or do you want us to zoom and show you?
It is visible, sir.
Okay. So the business intelligence came up and everybody is moving towards that, by seeing the right-hand side picture. So whatever they want to see, there are some indicators showing the progress, and there is a bar chart, and there is a trend chart, and on clicking any of these diagrams, you can see the drill down. When I see drill down, when you report at a country level some summary, total loan amount for this month at a country level, and the top countries or top branches on a particular product. So typically the top management want to see, when I say top branches, within the branch, how they are top, on what product they are making more money, right? That will be the immediate question it will come up. So they can do the drill down. The other type of drill down is which customers are contributing more. Typically, when you take any bank, the top 20% of customers might be doing more business. Remaining 80% could be very less business. So they would like to see which are those top 20% of customers and where are they coming from. All these things you can do through drill down options. That's why business intelligence reports are quickly adaptable, and everyone started moving into business intelligence reports. And the business intelligence reports, to create business intelligence report, now the latest tools are Tableau, ClickView, and there's one tool called BI. I forgot that. Those are the tools available now, and anybody can quickly do the reporting. If somebody is already doing some sort of reporting using some other tool, either a traditional Java, you write a code in Java to prepare a report or anything, can easily switch to these kind of tools. Yeah, next slide. So as we talked, information value chain is typically we take data from the real world. When I say real world, it is coming from social media. We'll take many data from social media to see. I can talk about why we are taking data from social media in the subsequent slide. And we also see the characteristics of particular person, the customer, how he is behaving, what kind of spending he want to do, whether he got promoted to new role, whether he has been switched to a new organization. Based on that, whether he can spend more money, or whether he'll become a defaulter. Those kind of information we get it from the real world events or characteristics. And the system data is nothing but the OLTP system. Typically the OLTP system data, which give all your transactions. And the location where you stay now. If you are typically you are in a Chennai person, and now you are in Andhra, or if you go to some other country, based on your location, give some promotional advertisements or promotional offerings for you based on the location. For that, you are also accessing the particular person's location, current location. And the data extract for analyze, getting data from different source systems like credit bureau data, and some other third-party data also we extract to do the proper analysis. And when you come to analytics, primarily there are three types. One is descriptive analytics, and then predictive analytics, and prescriptive analytics. I'll quickly explain what these three means. Descriptive is basically based on the insights. We have so much of data available. Using the data, give summaries, give drill downs, give particular trends, give particular patterns. All this will come under descriptive. Predictive. Predictives by the name, we are forecasting. With the current data, with the history data, we are forecasting on the future. That is predictive. And then even though we are predicting or forecasting, not necessarily everything will come to true. So to make it as an actionable item, we come up with prescriptive analytics. Using the predictive, example of predictive is defaulter trend. If you are doing some analytics and come up with these are the possible customers who could default due to XYZ reasons based on the analytics. If you give that information as a predictive analytics, using the information, prescriptive analytics is nothing but we have to either introduce new products or come up with if he is paying too much of EMI, whether we can reduce the EMI so that he will not become defaulter. Like that, they'll come up with actionable items using prescriptive analytics and introduce those things. That is what prescriptive analytics. Any questions? Is that clear?
Clear, sir.
Clear, sir. Clear, sir.
Move on. This next slide. So this we already covered. Typically summarize and interpret results. That is the primary part of analytics. And then you come up with the strategy, and plan it. Delivery as a pitch is an action item, and then take action. That's what we are doing using the analytics. It's not just seeing the report. We also do a lot of actions based on the analytics, what is coming up. Next slide. Who are the end users for analytics? If you take banking or any corporate as an example, the CXO team, they definitely would keep on seeing the dashboard, analytics dashboard. Which branch is performing well? Which product is coming up well? What are the top 3 branches? What are the bottom 2 branches? Like that, they'll be keep on looking into that. What is the sales happening? How sales is moving from every hour to hour or every minute to minute. They'll be keep on seeing that. So CXOs need analytics, and every vertical and horizontal unit head need analytics, and senior management also needs some level of analytics. It is based on the end user, that what they want to see will differ. And end customers like you and me, using bank, we are the end consumers of bank. We also need to see some trends. How my transaction is happening, what major spending I did, what major transactions I made in the last year, in the last quarter. Like that, we'll be seeing trend analysis. Will be seeing end users, and the regularity authorities need compliance analytics. Many of the banks, they need to follow certain compliance rules, and they need to report to the like in India RBI. In each country, there are regularity authorities where they need to share the compliance, and based on the compliance, where they stand against compliance, there are a lot of analytics. Based on that, there will be penalty applied to respective bank, or they'll improve the credit limit. Those things will happen, or they may even stop giving permission to operate. From that angle, regulatory authorities compliance analytics is very much essential and important. And the suppliers, there could be a lot of vendors who is supporting the bank. It could be merchants of credit card, or it could be collection department, outsourced collection department. They should also get measured and informed about their performance. So they also need analytics. Any questions on this?
No, sir.
No, sir.
Go on. Next slide, please. Real-time analytics. So typically, analytics used to be batch mode. We used to collect a lot of, we are using a lot of history data and coming up with patterns, coming up with the trends, and we use the sample data from the history, and then come up with using machine learning or some other techniques to come up with analytics using regression or what is it, classification, typically regression and classification. Within that, there are multiple methods within regression, within classification. So for all this, we need sample data and huge data. Typically that happen in a batch mode. But some of the analytics is happening on real-time mode. We'll talk about that in the use cases when we cover. Like example is fraudulent transaction. If somebody is doing a fraudulent transaction, there we need to do immediate response of stopping the transaction, right? So behind the screen, it is doing so many checks, whether the transaction is coming up suddenly huge. He was sitting in India, how come suddenly transaction is coming from US? And so many parameters. It will do so many combinations and come up with a decision on this transaction seems to be fraudulent. So that has to come real time. That cannot happen in batch. So that is one typical example of real-time analytics. Also, there is something called near real-time analytics. So the difference between real-time is immediate and near real-time, it could be the latency could be 15 minutes, it could be 1 hour based on the business situation. Okay, when you talk about real-time analytics, there are 3 factors involved. What is the time factor, or what is the lowest denomination of time you are talking about in data collection versus data ingestion versus data presentation? The example which I told you is about data presentation. Data collection is just that particular transaction. On that particular transaction, we are using the existing data and come up with decision, and then we are presenting yes, approve or disapprove. And then is your decision really depend on real time? If the decision is really not depend on real time, it is of no use. No use of making use of resource unnecessary, right? So whatever resource you are using, whether it is a CPU time or IO time or data load time, everything is cost. So if there is no reason to do real time, and if you are not going to do decision making on real time, you have to think about it doing in batch mode or near real time mode. So also when you do real time,
அது தனியா ஒரு ஸ்டோர் வச்சிருக்கா ஹிஜாபுக்கு முஸ்லிம் அவ.
Sorry, any question? Is there a question?
No, sir, please continue, sir.
Yeah, please continue, sir.
Okay. So also when you do real-time analytics, there are data is coming from multiple sources, correct? If 2 different sources is giving real-time data, there could be a data consistency issue, correct? One place we might be getting summary, the other place we might be getting detail, and the summary and detail will not match. So we need to ensure when you do a real-time analytics, what is the time latency of we are getting data, whether we are maintaining consistency when we present the data. Move on. So Gartner and Forrester, or the analyst, the famous analyst, they keep on giving business trends, who is on the better quadrant. They used to report about each and every customer. When you take they talk about the verticals, whether BFS is doing good or how BFS is doing, how healthcare is doing, how life science is doing. Within that, within BFS, which banking is doing good, which banking is doing bad, like kind of that. They'll give a quadrant report. Unfortunately, I have not taken the sample of the quadrant report. The primary purpose of this Gartner and Forrester is they keep on analyze the data about each and every vertical. Within the vertical, they check each and every corporate bank or manufacturing company or whatever, and they give update predominantly on a quarterly basis. They used to give on a quarterly basis. So these people, the definition what they have given on analytics is what is being shown in the screen. Probably you can read it. Typically, analytics is about prediction and future, whereas business intelligence is about the current data. Within the current data, give prescriptive analytics and diagnostic analytics. That is the business intelligence. That is the primary difference. Next slide. Are you able to read it?
Yes, sir. Yes, sir. Yes, sir.
Not, I'm trying to see whether I can expand the screen. Okay. Yeah. So what is the what it covers? What is covers in business intelligence and what covers in data analytics or business analytics? When you talk about the first one, visualization and the dashboard is coming from both business intelligence as well as analytics. When you do predictive or prescriptive also, there will be a dashboard. Okay, and identify pain points. It is also applicable for both. And reporting, yes, like dashboard, there are multiple reporting and visualization reporting comes from both business intelligence and analytics. And the descriptive analytics and diagnostic analytics is coming only from business intelligence. It is not the data analytics or business analytics area. Because as I told, business analytics need some lot of techniques, business learning techniques to process the data and come up with using regression or classification, come up with predictions. For that, it need a lot of CPU and memory and processing to come up with that output. So business analytics will not business analytics typically works on the sandbox environment. Probably when I talk about reference architecture, I will highlight that. And then predictive and prescriptive is available only on business analytics, not on business intelligence. Like we will not overload predictive and prescriptive using business intelligence reports. Next slide, please. Okay. Data model or data management. So to do whatever you want to do, whether it is business intelligence or whether it is business analytics, you need data. Everything works based on the data, correct? So coming up with the data management is important. What kind of data we need to maintain and where we need to. Okay, I've unmuted myself. Okay, so first primary thing is subject area or functionality. What kind of functionality my organization is going to cover? What kind of subject areas I'm going to using my business intelligence and data analytics or business analytics. Take an example. If the organization is using traditional OLTP system, and if they want to move to analytics environment now, they'll move one by one. They cannot, it is not a big bang environment. They'll go one by one. Probably first they'll go credit cards, or if that is, if they think that is going to add more value. And then they'll go to deposits and then loans. Like that, they'll come up with list of subject areas which they want to onboard into the analytics environment. And then data granularity. What level of data granularity we want to maintain in the analytics? Typically, we might have if customer is making each and every ATM transaction or each and every credit card statement will be there in the OLTP. When I move the data into my analytical system, whether we need data at this granular level or we need at a little higher level for a day summary or every transaction or every household level. Okay, so it's all based on what we want to achieve using the environment, using the data warehouse or data analytics environment, and what we need to produce. Based on that, they need to decide the granularity of the data which they want to move to analytics environment. Okay, we were talking about image processing and all. So when you keep on dumping each and every image, will that add value, or whether we need to move certain images like that? Okay, and the volume. What is the volume of data we are talking about? They have to come up with a quick calculation on per day, how many transactions it will come per branch. If I have thousands of branch, how it will come They have to multiply. Basically, they do a simple mathematical calculation and come up with what could be the possible volume per day, considering the granularity, what we are agreeing on. It is again based on the granularity, what they are agreeing on. Based on that, they have to come up with a volume, and then they have to come up with, they have to consider the growth rate. What today, this is the volume I'm thinking, but what could be the growth rate? What will be my growth in the next 1 month? What will be my growth in the next 1 quarter? What will be my growth in the next 1 year? They have to keep that also in mind when they come up with data management decision. And then master data. What kind of master data I'm going to use? And when I say master data, typically there are 2 master data. One is customer, the other one is product. This is the primary 2 master data if you take any corporate. Okay. And typically master data will get managed by master data management. There are tools available from IBM and many companies. They have provided their own master data management tool. Why people used to use master data management instead of custom build here is the primary challenge is customer identification. Okay. There will be multiple Sivakumar being the customer in the bank, right? There will be one Sivakumar in branch Chennai Nagar. There will be one Sivakumar in branch Hyderabad. How will they find out who's this particular Sivakumar, right? For that, we need to give an identification. We need to give a unique ID for a customer. How the unique ID will come up? We can easily think about and say, why can't I use first name, last name, and date of birth? Even if you use first name, last name, and date of birth, there could be a duplication, right? Then how will you resolve? So there is a lot of logic going behind to come up with customer identification. Okay. And when they make a change, right? They might have given a wrong name, or they might have given the attributes, whatever we are using to come up with customer identification. It could be a zip code or it could be a passport number, or it could be a PIN code, or it could be a city, whatever. When we give the KYC, we might have given a wrong information, right? Then we'll go and update. Then what will happen to the customer identification number? Like that, there are so many things involved when you come up with customer identification. So to not get into this complication, typically all the corporate world use master data management tool instead of they break their head to come up with logic. And then on top of the customer identification number, there is something called household key. Like I am having an account, and my son is having an account, my daughter is having an account, my wife is having an account. Then typically for analytic world, they used to create a household. For this particular Shivakumar's family, they'll create one key, combining my account key, my wife customer key, my daughter key, my son key, or my father key. Using that, they'll create a household so that they'll give offers at a household level instead of at a customer level. So that is also one of the primary reason why people use master data management tools. And then product hierarchy is nothing but when you talk about product, okay, we are taking a home loan, right? Home loan typically goes for 30 years. When they give insights, they'll give at a home loan level. Within the home loan level, they'll give, there are multiple sub products within the home loan. It could be a 10-year tenor home loan. It could be a 20-year tenor home loan. It could be a 30-year tenor home loan. That at the downside. On the upper side, the home loan will fall under loans, correct? It has to be grouped under loans. So loans, under the loans, home loan, it could be vehicle loan, it could be personal loan. Within that, there could be multiple sub-products. I'm just giving 3 hierarchy. There could be so many such hierarchies. So we have to maintain that hierarchy at a products, right? That is also complicated part. So not all the customers want to take that headache on their custom build system. So typically they use master data management. Is that clear? So master data management is one of the key items when you integrate your data analytics system. Okay, I assume it is clear.
Yes, sir, clear.
Running fast, okay. And typically you have to consider left to right or right to left or hybrid. I'll tell you what it is. So for analytics, to do analytics, as we saw the value chain, we are getting data from multiple sources, correct? So many sources we are getting data to come up with whether business intelligence prescriptive analytics or data analytics predictive analytics. So as we are getting data from multiple sources, we need to take a call whether I need to move my source data, all the attributes. There could be thousands. If you take credit card as an subject area, credit card has at least 5,000 attributes. Okay, I don't know whether you thought about that. I should have asked this question, right? Typically we thought if you say credit card, it could be 100, 200 attributes, correct? But as I was working for American Express, right? Credit card, when you make a credit card statement, it is generating close to 5,000 attributes. Okay, whether we need all those 5,000 attributes to process my analytics, whether we need 500 attributes, whether I need 50 attributes, the decision has to be made, right? Left to right means I just push everything. Just push everything into my source to my next layer. Right to left means I'm doing the data movement only based on my current need and what I could think I need in the next 10 years or 5 years. I'll move only that data. That is right to left. Hybrid is combination of both. Okay, I'll take right to left. On top of that, I'll also take some critical data from left. These are the decisions we'll make based on the discussions with domain experts, the corporate strategy making people, and architect, data model and architects. With the discussion, they'll come up with these decisions. Okay, and data lake is the term. Data lake means like lake. It is a stream of data. We'll move source data as it is, golden copy. We'll keep a golden copy of source data. Data warehouse is integrated layer. Data lake typically will have a source copy with a source structure. Whereas when it comes to data warehouse, it is an integrated environment. I'm combining multiple source data in an integration layer. So it is a the data, it applies some standardization, some transformation. With that, there will be a layer. It's called data warehouse. And data mart. Typically, the difference between data warehouse and data mart is based on the subject area. Like I told, if you take banking, it is a personal banking and investment banking, wealth management, correct? So typically, data warehouse will have all the data, whereas data marts, they'll create at a subject area level. So that the accessibility, they can give the access to the only respective people. Also, they can run the operations quick. So from that angle, we used to create data marts at a subject area level. And OLTP versus OLAP. Typically, your data warehouse operation data source. In data warehouse itself, there is an operation store and analytical store. Operation store is having about 1 to 2 years data based on the operations need of a particular vertical. If it is banking, typically we use 2 years data in our operational layer. Whereas in the analytical layer, we used to maintain 7 years data. And then there is something called, I have given at the bottom, historic requirement, right? In that, there is a retention policy. I need to maintain 10 years or 20 years data based on the country where we live. So beyond the analytical data, that is beyond 7 years, suppose if I have to retain 20 years data, the remaining 30 years old data will go into the cold storage. It means it goes to either tape or some other media where we need to retrieve based on the need only. Whereas hot storage is, it will be available on the existing servers. So we'll be keep on working on the data, that is hot storage. These are the terminology we use. Cold storage is, it goes to the offline mode storage. And data governance is one of the important topic when we are moving data to multiple places and multiple subject area data, right? And multiple attributes, and there will be a lot of NDA, right? NDC, non-disclosure columns or non-disclosure attributes like date of birth so passport number. See, these are some of the examples we should not supposed to disclose even within the bank to all the people if they really need not know about or should not see that. Correct. So from that angle, data governance is playing a big role in the analytics environment to give proper access to the right people at a attribute level. Okay. If you know the table, at a table and attribute level, not just a table level, and also some filters, some with some search criteria. And then handling unstructured data, we need to think about what kind of unstructured data we are going to use in the analytics environment and how we are going to process. That also need to, you have to think about that. And when you come up with the data management strategy, consideration or strategy, you need to think about how I can quickly onboard new source. Like I told, right? Initially, I'll go with private banking. Then I'll decide I'll add wealth management also. Our design or our strategy, data management strategy should be scalable or should be quickly should be able to onboard the new resource, new source or new subject area. We'll move on. Any questions on this? Okay.
Sir. No.
Here I'm talking more about what kind of business capability we need, and for that capability, how our environment should get enabled with. That is what it is talking. Probably you can go through offline. It is self-explanatory. You can go through offline. Move on. Next slide, please. If you want to read and have a question, please go ahead. If not, move on. Okay. So this is it possible to expand further? Great. Okay. So this is that reference architecture. Okay, it need not be the same. This is the reference architecture. As I told, data collection, right? The first block is basically a data. So we are getting data from multiple sources. It could be from first one I could not read. Software as a service. First one is software as a service. If you are in our corporate, we might have used some applications as software as a service. So we'll be getting data from there. We'll be getting from typical legacy system. We might be using legacy system for many years, right? And we'll be keep using the legacy system for our operational need. So data will be coming from there, and then data will come from social media, and so data will come from internet banking and mobile port. These are the sources, and also data will come from third-party sources. As I told you, Credit Bureau is one of the data we used to get it to get credit scoring of the individuals, right? We need to get some credit scores for each individual. So from that angle, we get data from third party also. It's not a corporate data, but third party data. And then once we capture the data, we are extracting the data, and after extracting the data, the sources, whatever we said, is either will go and fetch the data, right? Data has to get moved, right? We have to go and fetch the data from the source, the n number of sources on the leftmost block. We have to fetch the data on some frequency, whether you want to fetch it from the batch mode, or whether you want to fetch it from near real-time mode or real-time mode. Based on the decision, also we need to have a pull or push. whether we need to go and pull the data or whether they are pushing the data, and from there we are going to use the data, right? Those decisions has to happen. Based on that, we need to come up with our ETL, our loading routines, data loading routines. Also, some of the databases like Oracle and many databases, they have a replication feature available. Okay, instead of I go and pull, they'll create a replication of the data, and the replication can also happen on a frequency on what we are maintaining. Let it replicate or refresh on every 1 day or every 1 hour, okay, or every 1 month based on the need. So based on the replicated data, we'll consume instead of consuming directly from the source. And then change data capture. CDC is the future available again in many legacy system or databases and many applications. The CDC feature will give only the incremental data, right? What changes happen, that data only it will give. Incremental data means only these 3 possibilities, correct? One, you might have updated the existing data with a different value, or you might have added the new data, or you might have deleted some of the existing data, correct? Only these 3 possibilities. So these 3 possibility data will come in from CDC with an indicator. Based on the data, we'll go and process. So instead of go and fetch, right, they'll give this. So why we are streaming? Other one is streaming. Streaming is nothing but almost real time, right? They'll use some queue, message queue options. They'll keep on pushing into the queue, and will take data from queue and process. So this is are the some of the capture techniques, data capture techniques. Is that clear? So these are the decisions again we made at a source level. Whether the source again, these decisions are made based on how you want to process our data and what kind of access source system is giving to us, correct? Some of the source system, they will not give access to come and fetch data from their environment. They'll say, no, I won't allow you. I'll give only push. You cannot pull, correct? This is one of the example, right? And some of the source systems say, no, I don't have a provision to give real time. I can give only day end of the day. End of the day, I'll give a batch file. So based on, again, multiple parameters, we have to come up with capture strategy. And the capture strategy is typically at a source level. It is not at a overall data warehouse environment level. It is at a source level. Each and every source, we might have different capture strategy. And then once we get the data, typically the middle block is the different layers. Okay, we used to land the data, raw data as it is. There are multiple reasons of doing this. One, source may say, right, they either we go and pull the data, or they are pushing the data, whatever be the mechanism. If we keep the landing data as it is, any point of conflict, right, when there is a data issue or some problem, we have to go back and talk to the source system owner. If you are not maintaining landing data as it is, if you are directly transformed into our environment, we will lose the lineage. We call it as a data lineage. Okay, so we lose the lineage. So typically we maintain the lineage of this particular data, who has given, when they have given, what they have given, and how I am transforming. Before each and every layer, that lineage is getting maintained. This is again one of the compliance requirement. When the compliance people see the final output, they lost for the lineage. You are showing this report, you are showing this information, how you got this information. So you have to go through backtrace, how I got it, using the lineage. So typically, it's again, the architects and the business will decide what and all they want to maintain based on their business need. But the best practice is to maintain the landing data as it is in the raw zone. We call this a source golden copy also. The other reason why typically customers pull data from source and maintain source golden copy is I'm just holding for a minute. There is a noise. Okay, there was a noise, so I just stopped. So we also call that as a source golden copy. The other reason why we are maintaining source golden copy typically in our banking customers is most of the legacy system still running on mainframe. Okay, many legacy systems still running on mainframe. So we used to get data from mainframe. So whenever you go and get data from mainframe, you have to pay money to IBM. So it is based on the number of seconds or number of milliseconds, number of CPU used. Based on those parameters, they used to charge. Mainframe the IBM used to charge the customer. So wherever, this is one example, like that there are many cases. This is one example. Wherever there is a mainframe, we used to get data once and store it in the source golden copy. And the downstream, the subsequent downstream, whenever they need the data, they'll use from source golden copy instead of each and every one go to the mainframe. This is to reduce the cost. This is one reason why we to maintain. The other reason is to maintain the lineage. Okay. So once the landing data is done, then we do the refinement zone. Refinement zone is nothing but we do the standardization. Okay. One particular source might be giving data in kg. The other particular source might be giving data in liter, right? One might be giving in meter, one might be giving in what is it, yard or something, that different metrics, right? Different method. So this is again example. Like that, there are a lot in the business definition. So we need to refine it or standardize it. When people source is using different methodology, you have to refine and standardize that in the refined zone. Okay. And the unit of measure, and as I told you, the granularity also. One source might be having a different granularity, the other source might be having a different granularity of data. As we have taken landing data as it is, in the refined zone, we'll use the granular level what we agreed to maintain. And then integration zone. Integration zone is nothing but integrating the multiple source data into single layer. Okay, so that data from branch 1, branch 2, branch 3, for an example, all coming here and getting integrated. In the integration layer, most of our operation store analytics, that is descriptive analytics, will happen. They'll use this operation store. They use the two years data. Again, based on the need. If for the descriptive analytics, if they need only 2-year data, they'll use this integrated zone of the operational data store and use it. And then aggregated zone. Typically, aggregated zone is we need to create a lot of aggregations, right? We need to create a lot of summaries. We have a raw data and we standardize and transform, and then we integrate it. After integration, based on my business need, I need to aggregate. I need to do certain group by classes. I need to not just group by. Okay, it is not so easy to say why can't I use the group by function in the SQL and come up. No, you have to write a lot of logic to do the aggregation. So that aggregation layer, there is a data movement layer, ETL code. That ETL code will read from integrated layer and create possible aggregations or record aggregations and store the aggregations in the aggregated zone. And then there is called discovery zone. Discovery zone typically will get used by business analyst. Okay, instead of they use the complete production data. Okay, because if you are using 3-4 data source system, subject area, everything will be there, right? We have not done a data mart in this particular diagram. Even if you have a data mart also, before it goes to data mart, from the aggregation layer, there is something called sandbox environment. Sandbox environment is nothing but a playing environment for business analysts. Business analysts will take the data from the production, move the data into sandbox environment, and then they'll twickle data, the sample data they'll tickle to see how the analytics is performing based on their model. If I change some of the data, how the output will look like, how the analytics is reacting, right? For that, they need a sandbox environment. That is nothing but that discovery zone, typically a sandbox for them to play around to come up with a final model. The analytics is a big chain, right? They have to keep on applying multiple analytics, and then they have to productionize it. Once they productionize it, the particular productionized analytics will run on the production environment. Even though if it is productionized, doesn't mean that it is productionized forever. They'll keep on doing changes, altering the changes based on the business need. And then the last layer is presentation layer, right? So how first is accessibility. What access we have to give to whom? And then virtualization, how we can virtualize the data so that particularly the virtualization, how it works is it uses the cost-based optimization method, and typically it uses the database wherever we are storing from the database inherited cost-based utilization or cost optimization techniques it will use instead of processing again and again, right? And then they'll give some APIs connected to the APIs, and then data services. They'll provide EBS, enterprise data bus. They'll be provided. They'll give access to the enterprise through data services. They'll give access. I think 425. Data science typically using business analytics team and operations team will be using. And what is that? Data analytics. I think this is nothing but after the access layer, based on the usage, based on the customer, they'll access the specific data mart, or they'll use the aggregate data or integrated data. The access will be given through the program what they are using. Is it clear? I did not talk about metadata, right? Data governance I covered, master data I covered. Administration, also the administration is nothing but the security. What security we are going to give on what data and what time. There is also time and what subset of data that is come under security. Metadata is nothing but data about data. There is metadata. I talked about data lineage, right? To do the data lineage and to have a business glossary, we need metadata, right? You have so many attributes and so many objects. There is a business definition will be maintained. We call it as a business glossary. That is one metadata. And then that we call business glossary or business metadata. And then the technical data metadata is nothing but data movement from one layer to other layer, and what tools we are applying within that. That is getting maintained in the technical metadata. Technical metadata will get used for multiple purposes. One is, as I told you about compliance. Compliance will ask that. And as a business analyst, if they see some figures in the analytical report or prescriptive report, if they see that no, this data is wrong, then as a system support person, you need to look into the technical metadata and see the lineage, right? How I got this data, from where I got, what I got from source, how I computed, and how this final data come up with, right? To give this support and to work on that, we need the technical metadata, that lineage. And then the other one is optimization. Using the technical metadata, we can find out for each and every, typically batch loads will run on the night time. If it is a batch mode, whatever be the frequency, batch or real time. If the load is taking time, right, we need to optimize to know whether my load is taking time or which part of the load is taking time. We need the technical metadata again. Look into the data and then we'll optimize wherever the critical path is getting missed. We'll go and fine tune that or come up with a different strategy there to see whether we can meet the SLA, right? Every day the data has to get loaded within the day, right? There is a time frame, there is a SLA. If we miss the SLA, a system team is accountable or will get penalized by the business team. And it will get impacted by the customer too. Customer satisfaction index will come down if the SLA is getting missed. So these are the critical things in optimizing the load, completing the SLA. The SLA is being managed or being tracked at a senior management level. If there is a even 1% dropout, there will be multiple questions to the system team and architecture team. Any questions so far?
Participants are asked
Okay, move on to the next slide.
Participants are asked to be interactive. If you have any doubts, you are asked to.
No, ma'am. We can proceed.
Okay, data movement. Data movement typically will happen through ETL or ELT. Okay, and what needs to be considered when you do the data movement? That's what we are covering here on a high level. ETL is extract the data, transform, as I told you in the refined layer, right? We are transforming and then load into the integration layer. That is called ETL. And there is a concept called ELT also, extract, load, and then transform. Some of the database have higher efficiency in doing it through, instead of doing it through ETL process, do it at a database level. Some of the transformation they can directly do at a database level to improve the performance, right? So based on the database, what we are using and based on what kind of transformation we are going to do within that, it could be again both also, right? Some of the transformation can happen through ETL, some of them can happen at ELT. So that decision will happen, that consideration will happen. And I talked about standardization of data, what kind of standardization we are going to do, what level of granular level data we are going to use, what format, and what kind of data unit we'll be using as a standard. And handling real-time, near real-time, and batch. We need to have the data movement architecture should handle all this. And rejection record handling. Okay, so when we load data, it could be pull or push. Okay, we are pulling or they are pushing, whatever method. Once we process the data, there is a possibility of rejection. Okay, and in the when we use a source golden copy, the possibility of rejection is very, very less. It is 0.0001% because we are copying as it is. There is no rejection because we are not doing any validation. We are not doing any transformation. The 0.001% possibility of rejection could be server full error, environment error, something like that. But in a typical manner, if you are not using a source golden copy, if you are pulling the data, okay, and we are doing some validation while loading, there is a possibility of rejection, and the rejection can happen in any level. There are multiple layers I talked about, right? Rejection can happen in any layer. Whatever the layer rejection is happening, we should be able to handle it properly, right? The easy, quick, dirty way is stop the process, right? If you stop the process, everything will be on hold. Instead, we should have a mechanism to move the data into some error mechanism, error mechanism tables, and process the remaining data as it is, if it is not a showstopper. Okay, some of the data could be a showstopper where we need to stop, we cannot proceed. Some of the data we can live with it and proceed without with skipping those records. So if that is the scenario, we have to move the records into rejection handling and then process the records. And then we should have a mechanism or consideration to close the cycle, right? When I say close the cycle, how the rejected record will come into our system again, right? So there should be a handshaking back to the source system, and then source system has to give the revised data on that, and we should not duplicate the data in our system on that. So those many checks has to happen in rejection handling. Also, we need to consider when you move the new source or when you come up with a new analytic environment on these two environments, there is an initial load will come into picture. Okay, initial load typically has huge data, right? You are moving the source into you are moving the subject area or source into our analytics environment freshly. So we need to move the Oh gosh, I'm running out of battery. Sorry, I'll quickly run through. I'm very sorry. I'm in a non-city where I don't have a power plug here. I'll quickly run through. Can you move on the next slide? This is almost similar. Apart from that, I have highlighted here is analytics reference architecture, where I talked about what kind of tools is getting used in different layers. And I also talked about data virtualization as a separate box on what we are doing in a data virtualization before we consuming the data on the rightmost block. Okay, probably as I'm running out of battery, we'll quickly run through in another 5 minutes about the rest of the slides. Any questions?
Sir, can you please connect through mobile, sir?
Yeah, I can connect from mobile.
Yeah, this slide show is there. You can click on.
Yeah, so if I get disconnected, okay, I'll join from mobile.
Thank you.
Okay. So so we are in the block. It is a big data environment and traditional enterprise data. That is nothing but our operational traditional legacy data, and then what data we are getting from cloud using cloud applications. How the data is getting moved. Typically from big data, there is something called Scoop. We use that tool to move the data into our data warehouse environment. And typically on the legacy traditional enterprise, we use ETL methodology to move the data. And on the cloud applications, we use the CDC, that is change data capture technology, methodology to move the data. Typically for batch, we use a map reducer as the tool. If it is, and then from map reducer, it will get processed and then it will get stored into the Hive database. And when you use NoSQL, HBase or something, streams, we are using for stream data, it is called something called Storm. And NoSQL, typically HBase or even any other NoSQL database. For search, we are using Hunk, Solar Hunk. And SQL, we use Spark Drill. Typically, again, there are multiple tools. This is some example. Sorry, I need to connect to my mobile. Almost dying.
Yeah, the link is in your WhatsApp, sir.
Participants are requested to give your queries in the chat box.
Am I audible?
Yes, sir. Yes, sir. You're audible. Audible, sir, very much.
Okay, okay. Okay, and then the next slide is, so this is some of the sample banking dashboard, right? See, instead of tabular form, when they see like this, they are having a revenue by branch, right? Within the revenue by branch, Hong Kong and yeah, branch name. And so typically here, once they see this, they can go to the drill down. Most of the dashboard or most of the business intelligent reporting tools like Tableau, ClickView, Power BI, and all have the flexibility. They are all using in-memory analytics or in-memory architecture. So they can store or you keep the data, huge data in the memory. And when you do a drill down, suppose you're seeing a branch right here, revenue by branch. Within the revenue by branch, if you do a drill down, it will give at a product level. Within that particular branch, which product is giving what revenue? Or they'll give an option to choose product you want to do drill down at a customer level or product level. Okay, or they may even give a date range, whether you want to drill down at a particular quarter or particular month. Those things are very much feasible by using this kind of business intelligent descriptive reports if you use the right tool. And then top 5 customers by revenue, top 5 branches by expense. It's all by definition or by the naming, you know that it is all descriptive, right? There is no analytics coming in here. It's just calculating the value from the current operational data or using the history data also based on reporting need, whether they need to use only last 2-year data from operational store or whether they need to use 7-year data from analytical store. Next slide. Sorry, what is it? I missed it. I did not hear the question.
No, the question, it's not a question, some disturbance, sir. Please continue.
Oh, okay. Can you move on to the next slide?
Yes, sir.
Oh, I talked about this slide. Okay. I'm opening the other phone for the file. Okay. Because here it is very small. So I opened in the other phone. The next is again another sample of business intelligence report where you'll give the input. Typically, based on the consumption, based on the business analytical user, like we saw CXOs, horizontal head, vertical head, stream, portfolio leads, like that. Based on that, the dashboards will differ. And typically, some of the not at a CXO level. CXO level is just a dashboard. Typically, they may not choose the input like this particular screen where you can see at the top portion, you will choose the date and whatever period, filter, and then get, right? This is at a little, not at a, definitely not at a CXO level. CXO level dashboards typically just see the dashboard and they'll keep on seeing the movement, real-time movement within the dashboard. When there is a change, it will get automatically get refreshed whatever every 5 minutes or every 10 minutes, whatever frequency they want. So from that angle, the CXO dashboard should get optimized to that level to get the refreshment done. This is another example of giving the period or input. Based on that, the dashboard will come. Next slide, please. This is some of the use cases. As I mentioned in the agenda, we are talking use case at a very, very high level because I assume this will get talked in detail in subsequent sessions. In case if you need any more specific details on some use cases, we can have different ad hoc session, not necessarily within these 5 days. We can have different ad hoc session. So one of the use case here is propensity or uplift model. What is propensity uplift model? As a given, predict the customers who has an intention or likelihood to buy the specific products, or uplift their product. So how to find out that? We need to have some analytics. What data we need to use? We need to use buy data and sell data, and then use a classification. Use a classification model, classification technique to come up with what kind of customers is possible or potential to tick mark for this particular initiative. Okay, propensity or uplift marketing, right? The sales will, based on this data, once this data is getting done and when the predictive analytics is done, the predictive analytics data, based on the predictive analytics data, they'll know X number of customers or potential to do propensity or uplift product offering, right? Now, with the data, they need to come up with, if it is uplift model, they know which product they are going to uplift, right? He's using product X, we'll give him product Y also. Whereas propensity, we don't know what is the new product we have to give, right? We don't know yet, because is potential to use any new product. So based on the number of customers they identify, based on the region those customers fall in, based on the transactions what they are doing with, they'll come up with an action plan, right? These are the customers. This information is going to give by predictive analytics. They'll see those dashboards. Using the dashboard, they'll come up with prescriptive analytics on what kind of product will be suited by what segment kind of customer. Within the customer, they'll probably split into multiple segments. Within that, they'll find out which product might get easily sellable to this particular segment of customers, to this particular local regional customers, to this particular wealth management level customers. Like that, they'll come up with prescriptive analytics, and then with the prescriptive analytics, finally the sales team will go to the offer, rolling out offer to those particular customers with the recommendation what our prescriptive analytics is giving. This is to improve the sales performance, right? There could be 10 million customers in the bank. We cannot give product offer for all the 10 million customers, right? We need to two things. If you promote or give offer for all 10 million, one, there is a huge cost involved. Two, customer will get annoyed, right? If the customer is already in a painful status, giving some product offering may not work for him, right? We need to see how we can retain him, or we need to see how we can make him as non-defaulter. That is the option we have to give him, right? We need to give him some, we need to run some analytics and see whether we can reduce his EMI, or whether we can give some level of discount, or whether we can ask some additional collateral. Those kind of things we have to prescribe for people who are kind of defaulters or coming up at the default possibility of defaulters. Whereas people with this kind, we have to give the right product offering at a right frequency. We cannot also keep on sending that information every week, right? It could be a monthly offering, or again, business analyst based on the climate, like if it is a corona period, it could be a different strategy, right? If it is a stock market is going up period, or if it is a Diwali period where people are getting bonus, it's a different strategy, correct? If it is a 31st March tax filing period, it could be a different strategy. Like that, they'll come up with a right product offer based on the region and based on the period, and then they'll promote that to the right customers to get beneficial. That is the first case. Second case is spending power prediction. So here how much money he can spend more on buying new products. Okay, this is a regression prediction model. Using the regression prediction model, using the size of the products what we sold to other customers, and then they'll find out the like-minded or pattern matching customers and see whether these customers also may buy these kind of products, whether we can increase the product size or spending based on the spending power of the customer. Again, not necessarily only from the transaction data, they'll also look into the social media data, right? From the social media, they may find out, hey, some customers might be moving from one organization to other organization with a different role, with a great jump, right? Some organization may announce huge increment. Some organization might announce promotion rate is high. Based on this data from external sources and social media, okay, some of the customers, right, they might have update their status in their Facebook or Instagram about their promotion or about their increment, or LinkedIn, they might have updated about their job move. Using all this data and the transaction data, it will recommend the power prediction for the customer, and then they'll target those customers. Okay, that is a power prediction. And then third one is rank the customers on with the multiple products. Some of the customers might be ready to buy multiple products from bank, right? So they'll rank based on the analytics. They'll rank first preference is this product, second preference is this product, third preference is this product to offer this particular customer. Okay. That is the product recommendation analytics. We use multi-class classification here, or ranking technique. That was a technique being used to come up with this analytics. And based on the analytics, sales team has given the offers, product offers, based on the priority or ranking the analytics has provided. Any questions? Maybe move on to the next slide and then we'll ask for questions, as people are not asking questions. Move on to the next slide.
Yeah, we can move to the next slide, sir.
Okay, these are some of the analytics we typically do with customers. Customer segmentation, right? I talked about this in the previous case study also. We need to segment customer based on region, based on their interest level, based on their potential, and so many factors. Based on the segmentation is not just single segmentation, right? Based on the strategy what we are taking, based on what we are going to promote, there could be multiple segmentations. The attributes we use to do the segmentation will vary based on what we are going to achieve, right? So it's not just one segmentation assigned to the customer. There could be multiple segmentation one customer will belong to, based on what business is trying to achieve with the customer or what they want to promote with the customer. Fraud detection, I think we talked in the slide when we talked about the data management. I think it is both real time and batch. Definitely real time will be there to detect fraud, and in case we missed any fraud, batch also it will be sharing. In the batch mode, fraud detection will happen on the transaction, and it will trigger potentially this could be a fraudulent transaction. So then they'll connect to the customer, they'll make an inquiry and make the loop closed. They'll say that whether it is really a fraudulent or a normal. And the AML, AML is anti-money laundering. In case we don't know the exact. When it comes to foreign currencies involved, foreign transactions involved, even in the local currency transaction also. There are multiple tools available, products. When I say tools, products available. Again, banks will not write their own custom build to decide the AML. Instead, they'll make use of those products they'll pass on our transaction, and the transaction and the product will tell whether this particular transaction look like AML or not. Based on that, they'll take action. It is both real time and batch, but predominantly it is batch. Except the amount is huge, or some if they see some filters they apply on the transaction. If the transaction falls under those filters, it will be a real time AML detection. Otherwise, predominantly it is batch detection. Risk modeling is important thing for bank, because bank is running based on loans, right? It could be a home loan, or it could be a whatever loan, personal loan, or whatever loan, vehicle loan. Typically on loans, they are making money, right? When they give a lot of loan, and if the customer is not paying back, what will happen, right? They'll go, they have to write off, right? They cannot write off so much of money. So they'll come up with multiple risk modeling. It is not just one. If you take American Express as an example, American Express is running close to 500 models every day. Okay, to detect potential risk customers, and then they'll take action. It is not just one or two; it is 500 models being run every day with different combinations. And then customer retention. Typically, this is one of the important analytics again for bank. They don't want to, anytime they don't want to lose customers, whether it is a good customer or bad customer. Okay, and especially good customer. Bad customer also, they'll try to see how they can do a win-win situation. And as I told you about expanding the EMI period, or getting some additional collateral and gives more amount. So many combinations they'll try to do and try to retain the customer. So to retain the customer, one of the important aspect is satisfaction, customer satisfaction level. Okay, that index is being derived from analytics based on the interactions and the queries what they made with the bank, and then other aspects like default status, risk status, and so many other status. They'll decide and come up with this particular customer is potential to lose. So try to talk to them and come up with some strategy to retain. Some kind of prescriptive, prescriptive analytics data points it will provide. Based on that, they'll outline them. And then other one is product profitability. We have so many products in bank, right? And which product is giving more profit? If some product is not giving much product profitability, they may think about expiring those products. They'll support only to the existing customers, and they'll not promote anything further. And try to fine tune, if it is not profitable, how we can fine tune, where we are losing money, or where we are why customers is not buying with a huge amount. Like those, they'll find out with the output. So product profitability is one of the major important analytics or descriptive analytics. Descriptive analytics the customer will use. It could be for all the verticals. The point number 2 and 3 predominantly will come under banking, whereas rest all will come under all the verticals. And then earlier server failure detection. As I told you, the data lineage, right? Technical metadata. The technical metadata will be very useful to come up with this earlier server detection. Right? I keep running this data loads, and based on the server logs and data lineage metrics, it will come up with recommendation of these servers are potential to fail soon. There is a warning here. Try to work on that. Something like that. It will warn, and then they'll work on that server before it gets failed. And then the customer 360-degree view is the commonly used dashboard. It is a combination of multiple analytics output, both descriptive as well as prescriptive. Based on that, it will come up with dashboard about the customer. That's all. I think I completed on time. And is there last slide is question and answer. So you have any questions? You can give the feedback. I don't know how much useful it is. Based on the topics, I decided the foundation is important before we get into more details and more advanced. The purpose I thought I'll cover. I thought of covering the aspects what I covered.
It was indeed very useful, sir.
Sir, doubt, sir.
Yeah.
Sir, I am Kadirula Kumar from Virudhunagar near Madurai.
Yes, Karun.
Sir, in the data analytics, you have developed one module or app. Whether the result which comes from the data analytics always correct, or how much error threshold you have given?
Okay.
One question, sir.
Okay.
Second question, based on some transaction and the information, we conclude about the customers or some items or some object, something. But how much frequency, I cannot use the term. So once you have predicted based on some current transaction, then how you will redo the same work on the way, same transaction, same information? Because the data may be changed after some time, isn't it, sir?
Okay.
So at the time, suppose some customer or some of the item may be treated as a bad, maybe in future it may be treated as a good. So whether your app, not your app, this app or
Model.
our data analytics will redo the work based on the future transactions.
Okay. I think I got your two questions. Okay. It is instead of calling as an app, you can call it as a analytical models. Okay.
Yes. Yes.
We call it as analytical models.
Model.
So so the analytical model, what we are finalizing. First question is error, right? How much of error it could be?
Yes, sir. Yes, sir.
Typically, when it is a life cycle of finalizing the analytical model. In the life cycle, there will be, as I told you, right, there is a discovery environment, which is nothing but sandbox environment.
Okay.
In the sandbox environment, analyst will move the production data, okay. Based on what data they want to move, right? It is their choice. They'll move the data from production and they'll manipulate the data in the sandbox because they are not playing in the production environment.
Okay.
It is a sandbox environment specifically for them to come up or test the model, even to come up with the model. Okay, for the model, what technique they have to use? There are multiple regression techniques. What regression technique is applicable or will suit better for the parameters what I use and for the target what I am trying to come up with as a prediction, right? Okay. Typically, it is all based on how many parameters you are using for prediction and what is the target you are going to predict. Based on that, the regression methodology or classification methodology, whatever you are going to predict, will vary. They'll try with multiple things. Okay, they know their short list, but with the shortlisted list, they'll try with those things, and they'll see what is the success rate. What is the whether it is a 80% success, whether it is 90% success. They'll decide and then they'll announce also, right? They'll announce also based on this model. I'm getting 90% success. That itself is a good number. It need not be there is nothing called 100% success.
Yes,
it is always there is a variance. Always there is a possibility of we mark some wrong customers in a wrong classification or wrong prediction. There is a possibility.
Good customer. Is it possible to classify the good customer as a bad customer?
Oh, no. Typically, the model should handle that part. I can give more, but not less. Like that. Okay.
Okay.
So that covers the error percentage. Correct?
Yes, sir. Yes, sir.
If you have any further question, probably I'll try to answer. And then the second question you asked is data.
Yes, sir.
Data, as I told you, they are playing around in the sandbox environment. When the model is productionized, right? The model is getting run in a production data. It is not going to run in a sample data anymore. Because finally you want the output from the production data, not from the sample data. And it's of no use running the production model on a old data. It has to be always on the latest data.
Yes. Not need to be run in the old data, but whether the model allow the new data for training once again.
Yes.
Oh,
yeah.
Good. Okay, sir.
That's a continuous process.
Sure. That's what I want to know, sir.
Okay.
Thank you, sir.
Thanks.
Any other questions, participants?
Yes, sir. Your session is very nice, sir. Hello, sir.
Yeah.
The session is very nice and easily understandable.
Okay.
We can imagine what the system is going on in the banking environment or the other environment from your session, sir. Thank you, sir.
Okay, thank you. Any feedback is welcome. Even if it is a negative feedback, it will welcome. In case if I cover the similar session to others, if there is some improvement I have to bring in, I'll improve it.
Sir, I have a question.
Yeah.
Sir, is it in like we academics in research, we used to do the trial and error model, like to check what model is actually suitable and efficient for the data set we have. Is it the same with the industry also, or do you have any tips and tricks to identify which model will be suitable for what type of analysis?
Yeah, definitely there are n number of things available. If you take regression or if you take classification, okay. Within that, first we need to shortlist. Even to do trial and error, you have to do trial and error, not with everything.
Yes.
You have to do with a shortlist. And to the shortlist, how will you come up with a shortlist? It is based on, there are typically the people who are doing model is PhDs on statistics or that area. So they know which particular statistical model will be best suited for this scenario. Based on that, they'll shortlist. Okay, right? Each model, they know the background on what statistical things it is using. Correct? If it is K-mean, what it is using, they know. So based on that, they'll shortlist. And then with the shortlist, there is no other way than keep running the model on those shortlisted and see the success rate.
Thank you, sir. Participants, any other questions?
Sir, I have a question. How do you incorporate the forecasting and other details with respect to the analytics model? Forecasting, is there any possibility to add on?
No, forecasting is definitely required, right? Forecasting is one of the any prediction, right? Any prediction using regression. Using the regression, we'll come up with a forecasting. What within regression, what technique to be used? I need to I can update you based on specific scenario you have. I need to also go through now, and then I can come back offline. But give me the exact scenario on what you are trying to forecast. Whether you are forecasting a demand, whether you are forecasting sales, whether you are forecasting server downtime, server down. What are you trying to forecast, right? Based on that, we need to come up with the right strategy and algorithm. But give me your specific, I can update you offline.
For example, downtime, sir. Downtime
is easy. Downtime, it is, you have the logs, right? Server log. Every day we are taking the server log, and we have the data load also happening on the server, right? Suddenly the data load time is increasing 10% or 15% more, or beyond that, there's a potential problem. And if the server log says some warnings, there is a potential problem. All of a sudden, it will not fail, right? There will be some warnings. It will show some things is performing bad. With those parameters, we can come up on a high level. But I can give you more details if you want.
What
Later.
about the security issues with respect to this model, sir? How are we going to incorporate security measures, specifically with respect to banking model?
Yeah.
How do you incorporate security with respect to our analysis?
Yeah. When we started big data or cloud, banking was the sector did not go to or take up this big data or cloud initially because of security reasons. Okay. Now there are a lot of changes happening, and data security is covered, is taken care. And also using the access methodology, they are providing or they are restricting data which someone should not even see or others should not see. Right? They are filtering at a layer level. They are filtering at a layer level, at the physical storage level. Even if they use some data at a physical storage level, the security aspects has come up well. There are a lot of products now available to cover this aspect. There is no more threat. Still, there will be threat. Okay, in security, threat is there from the beginning in the legacy also. But banking has moved now, and every vertical has moved now. Keeping that in mind, the 99% is already taken care.
Thank you, sir. Thank you for your nice and informative session.
Thank you. Okay, any other questions?
I hope the audience have all the ideas clear. So thank you, sir. Thank you for such an informative session. A couple of minutes for a formal vote of thanks, sir.
Okay. Anyone can send questions if they have any, or clarification if they have any, even offline. I'll try to answer. Not immediate, probably a week time. Thank you.
I deem it a great honor to propose the vote of thanks to all who have helped us in making this International Congress on Industry Perspectives of Data Analytics Day 1 such a resounding success. I thank our resource person, Mr. T. Shivakumar sir, co-partner, Dews App LLP, former Senior Director, Projects AIM BU CTS. Thank you, sir. Thank you for your informative session, sir. Let us meet tomorrow at 3 p.m. with another interactive session on the topic Data Analytics with Machine Intelligence by Mr. Naveen Kumar sir, Media.net, Senior Software Engineer, ML Hyderabad. Thank you all. Thank you once again.
So thank you all, and wish we all meet at 3 p.m. tomorrow for another interesting session.
Thank you, ma'am. Thank you. We'll meet tomorrow.
you.
Bye.
Thank you, sir. Thank you, sir.
Thank you, sir, for joining with us, Kadirullah Kumar sir.
Thank you.
We are happy with your presence.
Thank you.
Please
ma'am.
join tomorrow, sir. To join.
Share, ma'am. Share. Okay.
Thank you very much, sir.
Thank you, participants. Kindly fill in the feedback form. And thank you, ma'am. And bye.